Okay, sorry for the interval in between. I had to avoid some background noise. So this is how you create a column vector and row vector. These are pretty simple, so we know these. Now, what we can do, what different we can like learn here is that, for example, let us first clear our display so that you can see things clearly. Let us again initialize a to a scalar value. So now a is again 5, and say for example I want to redimension a. Redimension a means that I want to now change the dimension of a. I want to turn it from a 1 by 1 scalar into something else. And this time I am not initializing it with any constant values. So this time I just say a. Okay. So what Octave will do is it will create a row vector, and that row vector will have 3 entries, and each entry would be a, that is 5. So now a becomes a row vector with each and each element of that row vector is 5. Okay, so like you can use a variable in order to initialize a vector. So here we are initializing a vector, a row vector, and we are using the variable a to initialize the row vector, and we are basically concatenating different instances of the variable a to create this row vector. Okay, so similarly here we like sort of created a huge row by concatenating these scalar values. So if we repeat this process, say if I do it again, if I say a is equal to a, okay, so now a is not just a scalar. We modified a, we converted into a row vector. So now a is a row vector with these 3 elements, and we are appending this row vector a with itself. We are concatenating 2 instances of the row vector a. So we will have a row vector that is twice the size of a. If you press enter, so this is the row vector that you'll get. This is the first instance of a, this is the second instance of a. Okay, so this is how we can append a in the form of an extended row. So this you can call this as concatenating one row vector with another row vector. And what it does is effectively that it places an instance of a to the right of a. So you will be elongating this row vector. What if we want to grow along the column direction? Say for example we want to add another row beneath this row, and then another row beneath this row. So we want to grow along the direction of the columns. So if you want to do something like that, you can do it using this operation. So what you need to do is you need to place the row vector a above another instance of the row vector a. So here we are using the semicolon operator. So basically we are separating 2 rows. So we are specifying this is our first row and this is our second row, and a, which is now this row vector a, it happens to be our first row, and then this happens to be our second row. So we can concatenate it in such a way. Similarly, now a is a matrix, and you can repeat this operation once again, and if you repeat it, so a will turn into something like this. So it will turn into a matrix that is double the size of the original matrix, and now its dimension is, say, it has 4 rows and 6 columns. So this is how you can like go from a single scalar value, and you can concatenate that scalar value in interesting ways, and the resultant vectors and matrices in interesting ways, and you can create matrices or vectors that are like very huge. So this is how you can merge or combine vectors or matrices to create even bigger vectors and matrices. Okay. We will try something else as well, and then we will go towards slicing operation. So let us take another example. Say we have another vector. We are creating another vector b, and this vector b is, say, this is our vector b. Okay. So we talked about this operator that is the transpose of b. Okay. So this is basically this single quote. So it will sort of find out the transpose of b. Okay, so it will convert a row vector into a column vector or a column vector into a row vector. So if I repeat this operation, b, which is a column vector, now it will be converted back into a row vector. Okay, so you can like use this operation within that process of creating new vectors. Say for example, we want to redimension b, and this time the way I want to redimension is that I want to have one column, okay, and that column will have the entries 1, 2 and 3. Then I want to have another column and it will have entries 1, 2 and 3, and then I'll have another column. Say I want to have 3 column vectors combined into a matrix, and each column vector has these entries 1, 2 and 3. Okay, so how can I do that? B right now is in the form of a row vector. Again, this is very trivial, but people who do not have enough practice or are new to Octave or MATLAB, they might struggle with these things. So this is, say, my first column. So what I did is that I basically converted this row vector b into a column vector using this operation, and then I want to append another column vector to its right. Okay, so if I want to append it to its right, then I need to just put a space character as separator. Okay, so if I use the space character, so all these column vectors will fall to the right of their previous column vectors. Okay, so this is what I'll end up with. Say for example, if say we start with the original vector b, and then I convert, say, b, I take its transpose, say for example. So, and if I do this operation using the semicolon operator, okay, so if I say okay, b was in the row vector form. Okay, so let us convert it back into the row vector form. So this operation will convert b into the row vector form. Before this command, b is in the column vector form. So when we execute this command once again, b will be converted back into the row vector form. So now I want to execute this command, okay, this command, but this time with a different separator. Like I want to say that now I have a semicolon between each of these column vectors. So now this is a column vector. Why is this a column vector? Because b is a row vector and b transpose would be a column vector. So this is a column vector, and then we have this semicolon as separator, and then we have another column vector, another column vector. So the effect of semicolon is like this column vector will be at the top, and then because of this semicolon, this column vector will be added below this column vector, and this column vector, the third one, will be added below this one. So we will end up with a very large column vector. So it will have, say, the dimension of that column vector will be 9 by 1. So the point of mentioning it was that I wanted you to learn the difference between using this semicolon as the separator between these column vectors and using space or comma as separator between these row vectors or column vectors. So I guess this would be enough in order to understand how to construct a vector or a matrix from simple vectors or matrices. So how you can combine two or more vectors. So the vectors can be different. They should not necessarily be B prime, B transpose, B transpose, B transpose, or A. So you can have different matrices, vectors. You can combine them in different ways. We can try something. Let us see if it works. Say for example, this is our A. So A is 4, 5, sorry, A is 4, 5, 6, and say for example this is B is this vector with these entries 1, 5, 9, say for example. So you can create a vector, say C is equal to, you can say C is equal to A prime, and after A prime we want, say, sorry, not prime, A transpose, and then after A transpose say we want B transpose. So C will have two column vectors. One column vector would be A transpose and the other column vector would be B transpose. So you can create something like that. Okay. Similarly, let us try, say, let us redimension C, and we want C to be C and say C plus 1. See if it works or not, or C times 2. Okay, let's see if it works or not. So it also works like this is the matrix C, and to the right of matrix C, because we specified a space character as the separator here, we have 2 times C. So you can do that as well. And say for example we want this to be the case, so we want C times 2. This would be a very huge matrix. So let us start with A, say for example. So so say for example we want to create D, a new matrix, and D will have one column vector which would be the transpose of A, sorry, the transpose of A plus 1, and another column vector which would be the transpose of 2 times the transpose of B plus 2, say for example. Okay, so we can do something like that as well. So B is this column vector 1, row vector 159. If you take its transpose, it would be 159 as columns. Is that B? No, we were operating here on A. So 4, 5, 6. So you add 1 to 4, 5, 6, so it becomes 5, 6, 7. And if you do these, carry out these operations on B prime, so this is what it would turn into. Sorry, on B, this is what it would turn into. So the basic idea of all this discussion is that you can create a vector or a matrix in Octave or MATLAB by merging, combining, or appending existing vectors in many interesting ways. You can do that. This would be the end of this discussion, and after that I'll demonstrate how slicing works, or how the slicing operator can be used. Okay, until then, goodbye.